Hello. Today we are going to cover one of the most important lessons in calculus, and that is the derivative. We will spend the rest of this school year studying the derivative and then the inverse function of the derivative, the integral. What is the derivative? It is simply the slope at a point. So, in calculus, the main study is we're looking at how fast or how slow things are changing. And in this case, we're talking about how fast or how slow our functions are changing. If our functions are changing quickly, the derivative will be a large number. If our functions are decreasing, then the derivative will be a negative number. This really helps us because it helps us maximize things, it helps us minimize things, but we will get to all of that later. All you need to know for this lesson is how to find the derivative. Now, here's how we figured this out. Mathematicians a long time ago had functions like this, and then they were like, well, how do I find the slope? Well, it's actually pretty easy. Let's say I want to find the slope at some point, and we'll call it x. Then what they did, and we'll call this f of x, they said, well, I want to find the slope there. In order to find the slope of a line, I need 2 points. We remember that from algebra. So I'm going to take another point here and use that point and this point to find the slope. Easy enough, right? What's the problem? Well, this point is kind of far away from that point. And so I'm going to get a skewed slope. In fact, if I were able to take a straight edge of some sort and put it up against my, wow, that is a messy whiteboard. Let's choose a non-messy whiteboard. There we go. And put it up there. That is not the same as the tangent line right there. I will draw the lines to illustrate. So this red curve is the one we want, but this green one is the one we got. So if I find the slope of the green line, it doesn't help me as much. But here's the trick. I am going to use the limits that we've learned to move this point closer and closer to this point here, so that the slope between these 2 points is almost right on top of each other, and that's going to give me the derivative. So, how do we define this point? Well, I call this some change in x, so this new point is x plus delta x. Okay, change in x, that's what delta means. And so our original point was x. If I add delta x, I get x plus delta x. So what do I get out of the function? Well, if I plug in x plus delta x, my y value should be f of x plus delta x. The trick here is that I want this change in x, or delta x, to be very small. And so I am going to take the limit as x plus delta x approaches 0. So here is the definition of the derivative. This is so important to your understanding of calculus. The derivative, and we will write the derivative as f prime of x. There's also another way we'll write it, but I'll introduce that later. Nope, I'll introduce it now. We can also call it dy by dx. Change in y, or delta y, divided by change in x. That's the slope, right? Rise over run. Here's our formal definition for calculus. It's the limit as delta x approaches 0 of, now, how do I find the slope of a line? Well, y2 minus y1, so f of x plus delta x minus f of x, right? y2 minus y1 over x2, x plus delta x, minus x1, x. If I let these x's go away, I get this. which is my formal definition of the derivative. So if I want the slope of any point on any curve, I can plug it into this function and figure this out. You guys have actually seen this many times before in pre-calculus, and so it should be a friendly reminder. Again, where do we get this from? If we jump back over here for a second, this point is x, f of x. This point is x plus delta x, f of x plus delta x. And so the slope is simply y2 minus y1 over x2 minus x1. Simple as that. So this is the definition of the derivative. We will have many others that tackle the problem a little bit differently, but let's try this one first. We'll start with an easy function that we should be very able to find the slope. Y equals 3x. Okay? Y equals 3x is easy because we already know the slope at every point. The slope is 3. So if we do this correctly, we should get 3. So let's apply our derivative. So dy by dx equals the limit as delta x approaches 0 of f of x plus delta x. So instead of y, I can call this f of x. So I want f of x plus delta x. So instead of plugging in x, I'm going to plug in 3x plus delta x. Remember from pre-calculus, when we have something strange going into a function, you plug that whole thing in for x. Now I'm going to subtract f of x, which is just 3x, all over delta x. Now you look at this and you go, well, I don't know how to evaluate this limit. Because I have delta x goes to 0 and the bottom is 0, so it's already gross. Well, let's just play with it a little bit and see what happens. So every time you write a new statement, you must write your limit. You can't skip it even once until you've plugged in 0 for delta x. So write your limit every time. If I multiply this out, I get 3x plus 3 delta x minus 3x over delta x. I'm really still not seeing how I can get rid of delta x or how I can plug in 0 yet, but I see that 3x minus 3x is 0, so I'll get rid of those. Now I have the limit as delta x approaches 0 of 3 delta x over delta x. Since there's delta x on the top and bottom, those cancel, and 3 doesn't depend on delta x at all, so the slope is 3. Exactly what we expected at the beginning. Let's try a harder one. Okay, yes, it does get more challenging as you go. And eventually, there are derivatives that you can only find using a calculator. So I'll show you how to do that at the end of our lesson. Although, for everything that you're given now in your book, you should be able to compute. So let's let f of x equal x squared. And we want to find dy by dx. Okay, now this time, we are not going to get a number. Okay? We're going to get a function that describes dy by dx that we can plug in our x value and find the slope. So don't be alarmed. So what does dy by dx equal? Well, it equals the limit as x approaches, or delta x approaches 0, of f of x plus delta x. You should always start with the definition of the derivative over delta x. Then I'm going to plug in. Again, rewriting this limit, I know it's annoying, but you have to write it every time. So if I have x squared as my function, then I'm going to have something squared. What do I have? X plus delta x. Minus f of x is just x squared over delta x. Now again, I'm going to do some algebraic manipulation here to see if I can simplify these expressions. So I have x squared plus 2x delta x plus delta x squared minus x squared over delta x. I'm still not seeing it right now. So I have x squared minus x squared. Those go away. That's cool. From the top, I see that both terms have delta x, so I'm going to factor one of those out. And I see that these ones cancel. Now, in the previous example, all of my delta x's canceled. In this one, they didn't. I still have one there. But since it's a limit, I can plug in 0 for that. And so the answer is 2x. So what does this tell me? Well, the slope anywhere along the curve of x squared is 2 times the x value. So in this next example, they want the slope for x squared when x equals 4. Can I do that? Sure. The notation we're going to use is we're going to write dy by dx at 4. Okay? So that tells us I'm plugging in 4. I already know the answer. It's 2x when I plug in 4, which is 2 times 4, which is 8. So the slope of x squared at x equals 4 is 8. You can do this a number of times with a number of different problems. Unique one that is quite tricky to do is this one. So let's let f of x equal 1 over x. So I like derivatives, and I'll write out the definition of the derivative while I'm chatting here. I love derivatives because it shows you where you're going. If your derivative is positive, things are going up, your function is increasing. If we're talking about revenue, if we're talking about something good, then that's great. But the derivative is also an indicator of when things are going wrong, when your slope is negative, when things are going poorly. And I always like to relate it to the Christian faith and say, let me write this out first. There we go. A lot of times you want those indicators in your life to show you how you're doing. The first one is your closeness with the Lord and that quiet time with the Lord. The second thing, people around you who can speak into your lives and say, hey, I'm noticing something different about you this week. I notice that you're struggling a little bit. I notice that you're doing these things that aren't great. It's like the derivative for your life. It's an indicator, oh man, I'm not going in the right direction. And so you can make that change. Derivatives are used in finance to show when things are going wrong in a company so they can fix it. It's actually really cool. So let's try this one, and then we will almost be done. So I'm going to find the derivative of 1 over x. Okay? So f is 1 over x, so I'm going to plug in 1 over x. Again, repeating my limit painfully. I have 1 over x plus delta x minus 1 over x over delta x. Remember, if you plug in 1 over your x value, and your x value is x plus delta x, that's what goes in the bottom. Now, what do I do here? Well, I know how to add fractions, and that's about all I know how to do here. So I need a common denominator, so I'll multiply this one by x on the top and bottom. This one's missing the x plus delta x. And after I've made those a common denominator, I have x minus delta x, make sure you distribute that minus sign, over x plus delta x times x over delta x. To get rid of this one, I'm going to divide the top and bottom by delta x. And those cancel. Now, on the top, I have x minus x. Those go away. And so I'm left with this ugly expression. Don't worry, we're plugging in 0 for delta x. We'll get you a little bit more visibility there. So I have negative delta x over x plus delta x, and then I have this delta x in front. So these two are going to cancel. And I'm left with, if I plug in 0 for delta x, negative 1 over x squared, which is the derivative of 1 over x. kind of gross, but it still works out. Now, there are instructions in your book on page 115 on how to find the slope using a graphing calculator. I'll let you guys do that on your own and ask me in class if you have any questions. That is problem set 19.